All right, so we began with looking at these typical appliance requirements. This is just a list of, various appliances that we have in the house. If we go back and we take a look at all of our specifications, right? So this is upstairs, downstairs. In this list, we have what had to go in it and the appliances that we wanted to put in there. So in order to calculate the electrical bill, we need to figure out what appliances are there, how much energy they use, right? The electricity, how long we're using them, and what is it going to cost us. So we're going to take this information from this sheet, which you can clearly see there are blanks. So some of you have already filled out these blanks, which you can do simply by knowing the voltage and current. You can fill in the power. Knowing the power and the voltage, you can find the current. So the first task is to fill this in. With the understanding when it comes to light bulbs, you can go to the store and get many, many different wattages of light bulbs. What you will notice here, though, is all of the voltages are 120 or 240. Anything that uses a lot of heat, like a hot water tank, the heat pump, and so on, is going to use, 240 volts. So when it comes to light bulbs, everybody uses them for a different amount of time as well. So we want to think in terms of, if I live there, how long would I use them? So for example, you can generically then put in your, like a 40-watt light bulb might be something you use in a closet. A 60-watt light bulb might be something where you would use if you have multiple bulbs in the same area, like in the bathrooms. If you have 3 light bulbs, you don't need any more than a 60-watt light bulb for each one of those. If you have a single ceiling lamp, you might want to use as much as a 100-watt light bulb. We'll talk later about all the new LEDs and all that kind of stuff coming out now that gives you this wattage, but it actually only uses like 15 to 25 watts. So that's definitely to save a lot of energy. So putting in 120 volts for each one of those gives us our voltage and our wattage. So based on the wattage and the voltage, we can find the current. We can also then find resistance. Just go ahead and leave this blank and we'll fill that in as we do our project. All right. So the first thing I'm going to do, let's go back and get you some notes on exactly how do we calculate the cost of something. So reflecting on what we do know, which is power is current times voltage, and that power is going to be in units of watts, right? We also know voltage is current times resistance. But what we pay for is power. And what we saw in problem number 5 is power is how much energy you use per time. So the other factor that's important in the cost calculation is time. So if we want the total cost of an object, of an appliance, it's going to be the power times the time in which I use it times the rate. So P is power. And since we use so many watts, this is going to be in units of kilowatts. TS. Your T is how long did you use it? And that needs to be in units of hours. So for us, we're going to do it per month. You can say per day or, things like that. And your rate is how much are you charged per kilowatt hour. So that is a kilowatt hour. So the prefix of kilo is used here because we use so many watts. So there are 1,000 watts in 1 kilowatt. Okay, 1,000 watts equals 1 kilowatt. All right, so our cost is power times time times rate. So put together this little sheet here to help organize everything by room. So here's what you need to do. I'm going to assign each one of you guys a specific room, that those of you guys that are virtual. So you're going to actually do the power calculations for everybody. You're responsible for your room, but everybody's kind of assisting since there's been so many of you been out. Others are assisting getting all that construction done. So you guys that are at home, you can do this paperwork a lot easier. So check your email regarding what room you're assigned, and this is how you would go about doing it. So let's say I am downstairs and I have the family room, okay? These are my appliances that I want to put in the family room. So that's the light above in the room. That's a lamp that might be on an end table, the television, stereo, fan, ceiling fan. So we'll begin by listing those here. So my room is the family room. The rate in which I'm going to be charged is going to be 6 cents for every kilowatt hour. Okay, so Virginia Power charges us about 6 cents for every kilowatt hour. That may be up. I haven't looked at it for a while, but I'm predicting that's about 6 cents for every kilowatt hour. So I'm going to write in here that I'm going to use a light. And since that's my ceiling light, I'm going to use the one that is a 100 watt light bulb. So that's going to be 0.100 kilowatts. So here we're going to write that in units of kilowatts. For my lamp, I might only use a 60 watts. So that's going to be 0.06. And then I have a television, right? And I think the watt, if I go back to my typical appliance requirements, and I find television, it has a rating of 300. So I'm going to go back here. .300 watts will be 0.3 kilowatts. So if I go back to my list, okay, I got the TV, the light, the lamp, I need a stereo, and the ceiling fan. So go back to my appliances, and up here is a ceiling fan, whoops, right here. And it's using 96. So I'm going to write that number down on my list. So we have the fan, and it's a 0.96, right? Is my watts. Everything here is 120 volts, 120 volts, 120 volts, and so on. And I think we also had the stereo, which if you can't find an appliance on here, there is no stereo. You could use the clock radio, would probably be similar. But if it's not listed here, you can look it up online. What's the wattage of one of those appliances to try to figure that out. All right, so that's where I will begin. For the cost calculations, it's these two columns that are important, that I simply need my power calculations. You can fill this in according to your chart. And since I don't have the chart, I have the chart, but for the sake of time, I'm going to skip right here to this time used per month and how we get this all done. So I go back over here, and in terms of lamps and lights, if this is my family room, more than likely we're in there for hours a day watching TV. So I'm going to say that I basically might use that light for about 5 hours a day times 30 days a month is going to give me 150 hours in a month. The lamp, though, I probably won't have it turned on very often, maybe 2 hours a day. So 2 hours a day times 30 days would give me 60 hours a month. For the TV, if I go back here, so remember, I said the time for each light you're going to determine. The other things, this is the average of the American household. So the television is on 5 hours a day, 150 hours a month. So I'm going to go back over here, and I'm going to write down 150 hours, which makes sense, matches my light. The fan, I know I personally run my fans all day long. So if I go back here to a ceiling fan, it has it on here as only 5 hours a day as well. I personally, I'm going to put that up a little bit higher because I want you to answer this according to what you think you might live if you think that's off. I run mine all day, almost 24 hours a day. So if I run something 24 hours a day, which would be like a clock radio, right? 24 hours a day, 720 hours, that's a lot of time. And what you'll find is that eventually adds up. But we can go with these ceiling fan calculations and give that time also 150. Okay, so what we need to do, I'm just going to do one of these and you guys can fill out the rest of this. You're basically multiplying these two columns to get this column, which if I go back to my whiteboard, power times time. So that's giving us one value there. That's this column, right? So if I do my power times time, that's giving us this column, which is a kilowatt hour. So 0.1 times 150 is going to give me 15 kilowatt hours multiplied by the 0.06, right? Should give me, on my calculator, 0.06, right, should be 90 cents, I believe. Or is that $9? So 90 cents is how much that light is going to cost us. So it doesn't seem like a lot, but as you can see, when these power, when your voltage, your current and your voltage is much higher and you're using a lot more power, that's going to be a lot more, right? So over here, this is going to be 45 kilowatt hours, right? So multiplying that by the 0.6 is going to cost us a lot more to use that. I think it's like $2.70, something like that. Again, I don't have my calculator in front of me, so you can calculate that, check on that calculation. But once you do each appliance in the house, and if you think you want something else in there, if you were to live there, add another appliance, give me the whole total for that room. You need a sheet, this sheet for each room. So print it out for every room that you are working on, and we will get the total for the entire house. The other important part is our total current. So I do want this in. I want you to scratch out the milli and just change that to amps. And we are going to completely solve all of these power calculations here. All right. So those of you guys that are virtual, your job is to complete the power calculations for the house project. So that's the goal. So the last sheet that I think I gave you is to total it all up, and we'll do that together as a class. All right, hopefully that makes sense.